Hi, this is Adrian from Live to Learn Academy, and today we're going to be going over trigonometric quadratic thinking problems. Now, this is a special request from some of our students in our program, so for those students who requested it, shout out to you guys. But without further ado, guys, let's get straight into it. If you guys have any questions that you want me to go through on this channel, feel free to drop it in the comments, and if you don't have any questions, feel free to like this video, subscribe to the channel for more videos like this, or share it to friends who are in need of help. Let's get straight into it. So this question says, solve this equation on the interval from 0 to 2 pi. So one of the things you guys want to look at when you're solving this type of equation is you want to recognize that this is kind of in the same pattern as a quadratic equation. Now, for those of you who don't remember, a quadratic equation follows the format ax squared plus bx plus c equals 0. So if you see this, it does kind of look like that, but instead we're using cos instead of, we're using cos squared x and 5 cos x, okay? So what we're going to do first is we want to factor this equation. So the way we're going to factor this is actually we're going to do a factor by grouping. And what we're going to have is 3 cos x, 2 cos x plus 3, minus 2 cos x plus 3. So this, all we did right here is we did factoring by grouping. Okay? Now from this, we can get our two factors. So the first factor is going to be 3 cos x minus 2. And the second factor is going to be 2 cos x plus 3 equals 0. So the first step, guys, you want to factor this equation because you recognize that it is a quadratic. Now we actually have to look at each of these factors to solve for x. So if I look at the first factor, I'm going to say this is 3 cos x minus 2 equals 0. 3 cos x equals 2. Cos x equals 2 over 3. So cos x equals 2 over 3. So if I see cos x equals 2 over 3, now I have to actually find out what x values will make cos x equal 2 over 3. So how we do that is we actually have to put it in the cast rule. So we have to find out which quadrants exist where cos is positive. So we know cos is going to be positive in this quadrant, and it's also going to be positive in this quadrant. And from our knowledge, we know that cos is adjacent over hypotenuse. So now we got to find out the two x terms. The first x term is going to be from here to here. We'll call that x1, principal arm to terminal arm. And the second x term is going to go all the way around to here. So we'll call that x2. So how can we find x1? First, what we'll do is we'll say cos inverse of 2 over 3 is equal to x1. So we end up with x1 is equal to 0.84 rad. If I know x1 is 0.84, then I know x2 is just going to be 2 pi minus the 0.84. And we'll be able to get x2 right away, which is approximately 5.44 rad. So there we have x1 and we have our x2. So you see how once we factored the equation, we actually had to solve for each factor individually. And in this case, because cos x was equal to 2 over 3, we had to use the cast rule, which put us into two separate quadrants. Okay, let's look at the next factor because we're not done yet. So over here, if I solve for this, I'll say 2 cos x plus 3 equals 0. Cos x is just going to be equal to negative 3 over 2. But this is interesting because some people might look at this and be like, oh, cos is negative, so it should be in the S and T quadrant. But the reality of it is negative 3 over 2 is approximately negative 1.5. And we know from our cos graph, our parent function, the parent function only exists from 1 to negative 1. So if it's at negative 1.5, that means we're talking about a point that's somewhere over here. Negative 1.5 actually does not exist in the cos function. So we actually get no solutions from this side of the function, or this factor specifically. So in this particular question, guys, and a lot of people mess this up because they start putting it into the cast rule, but the reality is it doesn't exist. So for this particular question, we only have two x values, and that only comes from this first factor right here. And there you have it. That's how you do this specific type of question. So let's move on to another type of question, similar concept, but let's try another example. So over here, we have 3 cosecant squared x minus 5 cosecant x minus 2 equals 0. The only difference between this type of question and the last type of question is that we're not using cos or sine. We're actually using the reciprocal, which is cosecant x. So the same process is what we do, but there's a little bit of a difference, and I'll show you that as we go on through the question. So the first thing I want to do is I want to factor this. So I'm going to factor this and say this is 3 cosecant x plus 1 and cosecant x minus 2 equals 0. And we're going to solve for each of these one by one. So first, I'm going to, and mind you, this question, I forgot to write it here, but it's in the interval 0 to 2 pi. So for this first part, I'm going to solve 3 cosecant x plus 1 equals 0. Cosecant x is equal to negative 1 over 3, which means now this is where that extra step comes in. We don't want to deal with cosecant x. We want to convert it to sine x. So sine x is going to be equal to 3 over negative 1. Sine x equals negative 3. Now, what do we know about sine x? Sine x, if we draw the parent function for sine x, we know that sine x only exists from 1 to negative 1. So if we're saying negative 3, it does not exist. So we know that from this section of the factor, we're not going to get any x values. So what does that mean? We ignore that section and we go on to the next section. So let's go over here. Cosecant x minus 2 equals 0. Cosecant x equals 2. So that means sine x is just going to be equal to 1 over 2 because sine x is a reciprocal. Now that I know sine x is equal to 1 over 2, I can actually put this into my cast rule. And remember, since sine is positive, we know we're going to be in this quadrant and this quadrant. And sine, remember from SOHCAHTOA, sine is opposite over hypotenuse. So if sine is opposite over hypotenuse, it'll be 1 and 2 and 1 and 2. Now notice here, this actually resembles a special triangle, right? It resembles a special triangle, the 30, 60, 90 triangle, or the pi over 3, pi over 6, 90 triangle. So we know that this is actually going to be pi over 6. And that means this is going to be pi over 6. So here's the thing. We have to find the two x values. x1, which will be from principal to terminal arm for the first quadrant. And the second one will be x2, which will be principal arm to terminal arm for the second quadrant. So x1 is pretty straightforward. We already know this is pi over 6. But x2 is going to be pi minus pi over 6, which actually ends up being 6 pi over 6 minus pi over 6, which is 5 pi over 6. And there you have it. You have your two answers for x1 and x2, and they both came from the second factor, right? They both came from the second factor, and we recognized which quadrants it is for the cast rule, and we also recognized that these are special triangles. So notice in the previous question, it wasn't a special triangle over here. So because it wasn't a special triangle, our answers were in radians. But in this question, because it was a special triangle, we were able to get it, it's still in radians, but in a more proper form using pi over 6 because it's a common triangle. Okay, let's move on to our last question, question 3. This one's a little interesting, right? The previous questions had 0 on one side of the equation, but here it's a certain function equals another function. So what we need to do is we need to first bring everything to one side to be able to solve this kind of question. So the first thing that I'm going to do is I'm going to say 0 is equal to 2 cotangent x minus cotangent x cosecant squared x. And now that I have this, I'm actually going to use greatest common factor to factor this equation. So this is not a quadratic. This is a different type of factoring, greatest common factor. I'm going to take out the cotangent x, and what I'll be left with is 2 minus cosecant squared x. Okay. And I'm going to solve for these two separately. So I'm going to solve for this guy, and then I'm going to solve for this guy. So let's look at this. This is going to be cotangent x equals 0. So what would tan x be? Tan x would be 1 over 0, which is actually undefined. Now here's the thing. A lot of people might look at this and say, okay, tan x is undefined, so it's probably no solution. That's actually not true when it comes to tan x. Because remember, how does the tan x graph actually look like? The tan x graph, remember from 0 to 2 pi, so yeah, we're talking 0 to 2 pi. So we have an asymptote at pi over 2 and an asymptote at 3 pi over 2. So notice how we have that asymptote. Here, I'll draw it a little better for you guys. But we have that asymptote here and an asymptote here. And the function kind of looks like this, and then it looks like this. So when it says where is tan x undefined, we actually know where it's undefined. It's undefined at these asymptotes. So those are our x values. Our x1 is going to be pi over 2, and our x2 is going to be 3 pi over 2. So we already got two x values from the tan x. Now let's look at the second part, the 2 minus cosecant squared x. If I solve for this, 2 minus cosecant squared x equals 0, I'll end up with 2 is equal to cosecant squared x, which is the same thing as saying 1 over 2 is equal to sine squared x. And then what I want to do is I want to square root both sides to get rid of the square. So I'll have 1 over root 2 is equal to sine x. But here's the thing. Remember, when we square root something, when we square root both sides, yeah, it's going to be 1 over root 2, but we have to remember this is going to be plus or minus 1 over root 2. And this is very, very common. A lot of people make this mistake. They just make it positive, and when they make it positive, they know that when they put this in the cast rule, they're only going to have it in 2 quadrants. But because we square rooted it, it's going to be positive and negative. So it's not actually just going to be 2 quadrants, but instead it's going to be 4 quadrants because we're going to have the positive and negative. So if I draw this triangle, it will be in all 4 of these quadrants, right? The C and T are where it's negative, and then the A and S are where it's positive. And we know that sine, remember, is opposite over hypotenuse. Opposite over hypotenuse. This is from SOHCAHTOA. So opposite over hypotenuse, opposite over hypotenuse, opposite over hypotenuse, but this one's going to be negative, and opposite over hypotenuse. So I'm going to have, in this case, I'm going to have 4 different x values. This is going to be my x1. This is going to be my x2. This is going to be my x3. And this, all the way around, is going to be my x4. And the beauty of this question is we actually know it's a special triangle. It's using the pi over 4, 45, 45, 90 special triangle. So we know off the bat, x1 is just going to be pi over 4. x2 is going to be pi minus pi over 4, which is 3 pi over 4. x3 is going to be pi plus pi over 4, which is going to be 5 pi over 4. And x4 is going to be 2 pi minus pi over 4, which ends up being 7 pi over 4. So this is an interesting type of question because over here, there's a lot of places you can mess this up. 1, if you don't factor it correctly. 2, if you don't put in the cast rule. 3, this question is this is a test level question because it tested your ability not to rule out the undefined. The undefined actually does happen because we know tan x has asymptotes, which means that there are x values where it's undefined. And then the second part is once you get to the square rooting part, you actually need to know it's positive and negative, so you'll have it in 4 different quadrants. So notice over here, you actually end up with 6 total x values, right? That's something to know for this question. So if you found these test level questions and these thinking problems, a lot of students struggle with the thinking problems on the test. If you struggle with thinking problems and you need tutoring, feel free to click the link in our description and our tutoring team would love to get in touch with you to help you ace this course. But without further ado, guys, I'll see you guys in the next video.